Right? And so the secular geologist is going, what are those creatures doing living in a zero oxygen environment? They shouldn't be there. This is called the black shale paradox. Right? How do you get these creatures living in a zero oxygen environment? Right? That's a big problem. Number two, there's evidence for extensive what they call bioturbation in some of these black shales. In other words, this is very interpretive, but they think that there's signs that the whole sediment was churned up by living organisms in the black shale. Well, how can that be if it's a zero oxygen environment? Same kind of problem. Number three, there's intervals rich of certain minerals that suggest oxygenated conditions. Right? And these benthic forms that kind of live on the bottom include these kind of things, agglutinated foraminifera. I'm sure you'll be talking about that at breakfast tomorrow morning. Benthic forms of agglutinated foraminifera are abundant and widespread in black shales. Those are everywhere. They're planktonic creatures that live on the bottom in today's ocean. They don't live anywhere else, right? And the black shales are filthy with them. How can those things be anoxic, right? Number five, as many as 14 erosion surfaces have been identified within individual shale layers, indicating shallow water depths on the order of tens of meters. In other words, the deep water model that Delta picture, 6,000 feet down, that's what they kind of talk about North America, 6,000 feet underwater. That's a little hard to believe, right? Well, guess what? It looks like there were periods when those shales were exposed to underwater erosion, and then they were deposited again, and they got beveled by erosion, and they got deposited again. In one deposit that's like 30 feet thick, they got 14 these different things that can be, and you can correlate these things for 100 miles, laying out tiny little layers like this for 100 miles in the Chattanooga Shale, from one outcrop to another, indicating something on an extraordinarily wide scale was going on. This was anything but the delta model that they'd like to go with. So this is a picture of the geologic timescales a secular geologist talks about. I want to transition now into talking about one extraordinary interval of black shale. Okay, this is your geologic column, right? You can take this with a grain of salt, but you know, the millions of years here, forget that. I don't believe any of that.
No.
All right? But I think these terms in a relative sense can be useful, personally. And I think that a lot of creationist geologists who say that you can totally discard the geologic column, I think they're kidding themselves. I think it's nonsense. Right? But in any case, I think you can use those terms in a relative sense. And there are periods in geologic history when it appears like these black shales were more prominent than others. All right, and so now I would interpret these same, geologic column in this particular way, right? That the layers under here are pre-flood, these are early flood, late flood, and then post-flood, right? That's the way I would interpret that. But we want to zoom in on one called the Upper Devonian, Lower Mississippi Black Shale interval. So anyway, I've just given you the introduction to that. Right? Now this is what's interesting. I composed this, I spent a lot of time putting this together from different sources, drawing this thing. It's kind of a map. Well, it's an approximate map showing that in this one interval in the geologic record, you've got one layer that's like, in places it's 30 feet thick, and a couple places it's 100 feet thick, other places 200, 300 feet thick. It's not very thick. It extends across all of North America. Right? Right? This is anything but the little delta model that they talk about. It's something extraordinary. And it's got these fossils in it. It's got these indicating oxygenated conditions and moving water with it, all that, And from this one interval come probably about 75% of your big oil shale deposits around the country today that you're hearing in the news. The Marcellus Shale in upstate New York, the Chattanooga Shale here, the Barnett Shale, that's what I was thinking of earlier in Texas, right? North Dakota, if you live in North Dakota, everybody's heard about the Bakken. You don't hear about it too much here, right?
No.
These are all, and this is big time stuff in Canada here, right? And so, everywhere the dark blue area is, these are prospective for oil and gas today, right? These are places in the US where they're interested in drilling, you better believe it, right? And the light blue are areas where it could be future, I mean, it's conceivable, but the evidence is that this layer at one time extended across all of North America. The Rocky Mountains were uplifted since that time, and they shed the material off, so this, but it's quite clear it extended across there as well. Anyway, that's a kind of a, well, what do we draw from this, right? Despite the multiplicity of names that appear to be this appears to be a single, relatively thin layer of organic rich black shale that probably covered the entire continent at the time. The best evidence indicates it accumulated rapidly in relatively shallow water meaning 100 feet, something like that, not super deep, but definitely underwater, in oxygenated, not under stagnant conditions of extremely slow deposition, no. This one layer of black shale of enormous economic importance defies a uniformitarian explanation and conforms well to a flood model of Earth history. Right, so pretty interesting. And to me, as a geologist. So just to summarize black shales and the Genesis flood, how do we tie these things together to the flood model, right? I got a couple of points here. Number one, flume studies corroborated by field evidence indicate that many, if not most, of your shales were deposited rapidly in the fast-moving water. That's point number one. That alone is terrific stuff to any geologist, right? Number two, benthic fauna, bottom-dwelling creatures, and other indicators strongly suggest the burial took place under shallow water, oxygenated conditions. Modern-day analogs just don't even come close. It's a joke. They're trying to pound a square peg in a round hole, and we should be the ones to tell them that, right? They're trying to force this model on something that really is, you could almost cry for these people, right? But this is what they're stuck with. The persistence of the Devonian, Mississippian black shale intervals suggests the entire continent was at one time swept by shallow, well-oxygenated moving waters. Preservation of organics was due to rapid burial, not anoxic conditions. And okay, did I repeat this? I did, didn't I? Appears to, I threw this together pretty quick. Okay, so yeah, so I'm interpreting now. The Devonian Mississippian black shale interval, relatively thin sequence of rock, points to a unique period during the flood when apparently all of North America was underwater. It appears to coincide with a period when during the flood, when the perimeters of the craton were contributing sediment for the first time. It looks like it was ringed by mountain ranges. It was a unique time during the flood, and it was, I think, a turning point during the flood. Right? So it's a place to hang your hat on in terms of, okay, how do we break down the flood record here? So I think this is, so one thing you can say with the old Delta model, it's fallen on hard times, right? Here's what they've replaced it with, because they don't want to believe in a global flood. They believe that there were, in Earth's history over millions of years, the oceans underwent crises, environmental crises, where there was, the oxygen level was cut off to those poor creatures living on the sea bottom, and it deposited these black shales all around the world. Right? And so there's an environmental twist on this today. And this is the direction of research today, because you follow the money trail, right?
Yeah.
And if you want to do research, well, you got to put that in front. What could possibly cause such crises in Earth history? Climate change. See? So I might not get my money for funding if I write in my research grant. I'm doing research on oceanic and oxic events in Earth history. But if I happen to mention it's related to global warming, oh, the money flows. You see. So should it surprise us very much that all the research is pointing toward Oh, that global warming is a fact, you see. This is a fact we've got to deal with today. I'll tell you something, if you want to dissect the anatomy of a fraud, the whole global warming one is really one you can really analyze, and you can see the propaganda of the future, because this is what's coming at us today. Yeah. Okay, sorry. It's driven by politics, not by science. Yeah.
So I was wondering, how does that solve the problem of the fish and the worms together? Because if they're wouldn't they have, if it was anoxic, wouldn't they have just died and floated off somewhere else? I'm not quite sure how that solves that problem. Can you explain?
Well, you're right. They have to stretch again. They have to reach here. What they say is that, well, some of these creatures, they may have been somehow carried in the waters above that were oxygenated, and then when they eventually died, they fell to the non-oxygenated waters at depth, and that's how they got pickled down there. But you're right, it is a big problem, and so a lot of the challenges I brought out to you in the black shale paradox, they're a problem for this interpretive view also. Yeah, you're right. Yeah, and so not everybody buys into this, the OAE kind of view here. Not everybody does who are secular geologists. Right? Yeah.
So you were showing us a map of the black shale over the United States. What does it look like over the rest of the globe?
Yeah, there's similar things in other continents. Yeah. Not identical to North America, and each continent is got its own complexities to deal with, but similar, not identical though. Yeah.
So does that mean that each continent is required to have a giant inland sea?
Well, I think.
By the secular.
Oh yeah.
So they all were just little rims all over the world.
Well, they all have to say that they were all epicontinental seas on all the continents. Yeah.
Okay.
Because the evidence for the, I would say the evidence for the flood is worldwide. Yes. And they have to deal with it, and they call it epicontinental seas because that's their way of damage control. Right?
Give it a name.
Yeah. Okay, so isn't that interesting how they twist it into an environmental crisis, and this is the direction and people are kind of being led down the primrose path this way. It's frightful to me to see this. Yeah. Anyway, I want to look at, now we're shifting into the exploitation. I want to just give you some understanding, because I've got family that live in upstate New York, and there's a lot of talk about the Marcellus Shale, and a lot of environmental concerns about this and so on. I want to just try to, because I think education is the best way to understand how to deal with this. You want to know the truth of it, and then you can decide whether it's a threat to the environment or not, right? Get to the truth first, and then we can and then we can have an emotional debate, right?
Yes.
Okay. This is the Marcellus Shale in upstate New York. Looks like a sidewalk, right? Those are natural fractures. This is a natural outcrop along a riverbank. Those are vertical fractures in the shale. It's because of those vertical fractures that it makes it very good, very suitable for drilling for gas, natural gas, right? The objective is, because these fractures, they extend down into the earth like this, right? And so the objective when you're drilling for natural gas is you drill down your borehole and you kick it out horizontally and you penetrate as many of these vertical fractures as you can, because those are avenues for gas to escape into the borehole. You can produce more gas that way. That's the idea. All right, so now you understand that. And your outcrops, they all show this kind of fractured look. This is a natural outcrop in Pennsylvania, the Marcellus Shale. Very black shale. It's got upwards of 10–20% total organic matter. It's really rich, right? And vertical fractures in it, right? There's another one there near vertical fractures, and it's the fact that they're very regular and predictable that they can exploit these things very nicely, and they are doing it today. The scale of the Marcellus Shale, one particular deposit in the United States, it's one of the largest known natural gas provinces in the world, second only to a giant one in Iran, right? In other words, we are an OPEC nation when it comes to natural gas. From that one deposit in upstate New York, remember I had that map littered with, the blue map? I had it littered with a couple dozen names. This is just one of them, the Marcellus.